Back for the second part of the lesson. We are again here to our example. I clean the changes. So this is a definition of our class. Now I am related to the content. The class is defined. As I set up, I want to create 10 from 0 to 9 examples of the capital T class. Temporary, each example is named T, but I immediately lose T because I copy its content as last element of the T list. It is nice to deepen this detail. I add a cell below. Sorry, it is better to have it here. I add a cell below and I ask what the list contains. Your guess? What the list is containing? The? Yeah, but what of the objects? The others. Remember always this detail. These are others. Others. The contents of each self. The self of this 0 contains these others, the self of the 1 these others, and so on.
Here now we are in the code in the for loop. We are using capital T and I. No?
Yeah, I.
That I is basically our n, right?
N.
So we are not passing a value for self.
Yeah, we are passing I.
I is the value for self. I is the value for self.
No, self is generated by Mr. Python.
Okay.
It's not our job. We would become crazy if you had to generate the addresses. All the machinery I told you is hidden. But look here. The list is this, okay? What T of 0? The first instance. At what T of 0 dot n? 0. And what T of 0 x? The position. And so on. So T0 is the address of the instance. With a dot, I can search for all the contents. Do you agree? No? Ask, please. No. For I in range 10. It means 0, 1, 2, 3, 4, 9. What is a cycle? It's a machine to apply something in a set. Okay? What is range? But you are supposed to know Python. Okay. Let's see. Insert cell below. Range of 10 is the range of the number equal greater than 0, strictly less than. I is defined in this set. So I is 0, 1, 2, and so on. And our instances are 10 with their n values from 0 to 10. Okay? Good for everyone? Nope. I see that you are a bit concerned with this problem. Help me to understand what's the problem.
No, no, my issue is only that when we pass I, no, that normally when we define function, we have an order of variable, no? So if we have two variable, two parameter, okay? The first is the, no, it's the first parameter, the second is the second parameter, right? Here we are using T, capital T, okay? And capital T, when we look at the description of the code, we have self.
Yeah, but I told you that self is managed by Mr. Python.
Yeah. No, now it is clear to me how it works. But
Fortunately, it's not our job. This is the idea of the creator of Python, Professor Garroso. In Java, it's a lot more complicated. Then, the go step. For I in, I have created the goal in a general way. So if the setup is creating more or less than 10 instances, the go works anyway because it is parametric. The upper limit is not a number, but is the length of the list. So if I create here only 3, as an example, in 1, 3, 9. These are 3 instances with number 1, 3, 9. Okay, only 3. This works because now it will use a list of length 3. Mr. 1, Mr. 3, and Mr. 9 with their positions. Okay? Problems? This is only a nice addendum, that of the capability of plotting. And plot is very simple because we are using this library, PyLab, and we have defined PyLab as PLT, just to have a shorter name. And here I ask to PyLab to plot the position x, in the position x and y, a symbol, a dot, a large dot. Star means a large dot. And the effect is this one. Does not work? Ah, it is go, sorry. This go. This one. They have 3 here, here, and here. Okay? Simple. I will correct the detail of this example because I discovered now that it was not necessary to define PLT because I don't use it, I use the magic solution. If I don't use the magic solution, I did this. And in this case, this is unnecessary. I comment it. Don't care. and it works anyway. I hope. Yes, it works. Because the magic command supersedes anything. Okay? Stop. But please ask me now or after the lesson, by mail, personally, as you want. Okay? Log out, no. Close and alt. Sorry, I have created a lot of strange changes, so in this case I simply log out because I don't want to keep the changes. I close this and I quit. You see, this is not so nice as exiting way. The kernel is always running, so Control C twice and the memory is free. Now, the program of the second conversation is exercises in that logo, also considering the folder 4 and 5, but exercise in net logo, first of all, following the content of the folder 2, 3, and 4 of SLAP. What is SLAP? Is my code in Python mimicking the content of Swarm. I was explaining yesterday what Swarm is. SLAP is online in a Git. What is a Git? A Git is a repository mainly of code, but currently we are writing a book and we have a Git as a container of the chapters and all the pictures of the book, and all the data, they are in a Git. A Git is a not nice signification, then can explain us that means in a polite way unpleasant person. I am a Git, I am an unpleasant person. The translation in Italian is very hard, I don't use it. Why this strange name? Because the author is a special person. It's Linus Torvald. Linus Torvald is the creator of Linux. And he told of himself, I am a bit selfish. I named my operating system from my name, Linus. And I named my repository as I am. So he is explaining that he is a Git. He is a wonderful person because he has created two large gifts for everyone. Linux, which is the basis of anything now. You read that Mr. Microsoft, the Microsoft company, bought Red Hat company for about, if I remember exactly, 13 billions of dollars. Just to save Microsoft. Billions. 13. Yeah. Just to save Microsoft.
Almost half of an Italian budget loan for 1 year.
Yeah.
Almost half.
Yeah.
Italian legge di stabilità.
Don't open politics, please. And why? Because Microsoft is restarting all its job upon the open source infrastructure. Red Hat, with its operating system, is running the internet in the world. All the servers of the world are Red Hat based. Thanks to Mr. Linus Torvald, and its Git has created a lot of system. I am using that name, the GitHub. GitHub started as an independent company and has been bought in the beginning of the years by Microsoft, always. And if you go back to our syllabus, we see here that slap is here in a Git. Turn slap 3 in Git. The cat is the symbol of GitHub. And here you have 6 folders. From 1 to 5, they contain a tutorial. A tutorial to do what? To learn how to build object-oriented, agent-based systems. It is a wonderful tutorial, not created by myself, but by Chris Landon, the person that I was remembering yesterday, when he was a PhD student. So please do that. You are supposed at least to do that. And I recreated the tutorial in Python, and for you, for this kind of presentations, also in NetLog. So now, alone, because now we introduce, but we have, it's not interesting to spend a lot of time to look at codes. It's very annoying. But if you spend 1 hour, no more, 1 hour, to look at the contents of the folders reported here directly in our folder. 1, 2, sorry, let me enlarge. This is strange. It is already enlarged. What a strange situation. I don't understand, sorry. I don't know, I don't understand. It is already the max, it is very tiny. Sorry. 1, 2, 3, 3 bis, 2 versions, 3 ter, 3 versions. You understand a lot of things. We have 2 red dotted files. We look at them. Why? Because they are the object of your own work. So first of all, in NetLogo is always the tutorial. 3 in NetLogo. The name is suggesting the content. The name is Basic Object Programming Many Bugs. So we have a tool running more than 1 agents, bugs conventionally, in a basic way. Doing what? Moving around. Very simple. Very, very simple. Pay attention. The button Go is gray, not black. Why? Because with edit, I put a flag on disable until ticks start. It is to avoid error. If I try to press these buttons, they don't work. I make setup and now they are black. The content, very simple. Then you see a few rows. Let's enlarge. From the keyboard does not work because it is mapped upon a US keyboard. This is an Italian keyboard. Okay, now you can read. Clear all, create turtles. How many? And bugs. Oops, and where is it bugs? It's not defined. It is in the interface. This is the novelty. In the interface, we have a slider. This one. Please look at the screen. This one. And how can I create a slider? From this tool. Button, slider, switch, chooser, and so on. A slider has a min and a max value, and its position set the value. So here we are asking for 50 and for 50 bugs, and we want to run the simulation for 50 periods. Pay attention, I stress that we have two main cycles, always in a simulation project. In the case of the oligopolistic market built by Marco and myself, as an example, the cycle upon the agents is related to, in the beginning, 10 oligopolistic firms and 10,000 workers. So the main cycle about the agents have to ask to this two sets of agents to do something. Firms will produce, workers will work, but workers will also, and also the entrepreneurs, will also buy goods and so on. But we have a second cycle to run, the time. In natural experiment, this is always to be remembered. In natural experiment, the time run naturally. This is artificial. And in artificial experiment, the running of the time is our job. So two different cycles creating a lot of confusions. Professor Wilensky, Yuri Wilensky is the main author of that logo, had the brilliant idea of using the repetition of the go button to manage the time. In this way, internally, we have no cycles related to time. The time is not managed here. It's managed here. This is not possible in Python. We have, in Python, there is a lot of graphical user interfaces. So you can create an environment in Python with buttons, slider, or what you want. But they are terrifying complicated. So no one is using them. Maybe in the next future we will have a lot of widgets within Jupyter, simplifying anything. So Jupyter is very simple to use, you saw. If we can add, place in the screen buttons or slider or other objects, it is very nice. It is already possible, but there is a bit of confusion because we have more than one project around, but I am sure that maybe in next year or close we will have a stable solution. In the code, we create the turtles and we start the go phase, increasing the position of the clock with a tick. And if ticks is greater or equal to end cycle, stopping. Why greater equal and not equal? If the user restarts, is no more equal. We want to stop, finish. So if the user restart the code without cleaning it, the code does not work. If here I had only equal, it will restart. Pay attention. This is important. It is a detail, but it is a confusing problem. If, no, it was not supposed, it's a crash, okay. A huge crash, it's better to restart. If is a logical instruction. If something is true, do, exec, continue, follow what you want. If it is false, don't execute. Okay? The content of an if is a logical sentence. If A is equal to 3, drink a coffee. The desire of my friend Marco. Okay? How to write equal here? If you are in Python, don't forget that you have to use two equal signs. If you are in a NetLogo, only one. Why? Because in Python, A equal 3 is an assignment. In NetLogo, the assignment is set A3. So no confusion. This is a very bad use of the sign equal. A is not equal to 3. A is empty and we fill it with 3. Beginners are very confused by instruction like A equal A plus 1. Mathematically is impossible. A can't be equal to A plus 1. But this is not a mathematical sentence. It's an operational one. Assign to A the current value of A plus 1. Or you saw maybe that in Python I have been using this shorter construction, but it means the same thing. It is coming from C. A plus equal 1 means A equal A plus 1. Okay? Ask turtles to move around. You already saw that yesterday. Now I was, without fear of being wrong, I used -1 after 3. Without fear. Type, I am agent who, my name. Type, and I am in. Type, xcore. Type, comma, print, ycore. What the difference between type and print? Print is changing row, type is not changing row. So we continue to write to the same row. Very, very simple as program, you see? But it contains anything about agent-based programming. A set of agents. a function to be executed, the movement. Not declared, but it is there. The management of the time via the go. Anything is here. Let's verify if it works. Set up, ready though. Go, one step. Nice. If we continue having the steps of one unity, they are moving slowly and they are spreading around. If I switch off the writing instruction, the program will be very, very quick, because writing on the screen is very slow in any environment. Let's see. Go. You see. 50 step immediately. Set up. Go. Finish. If I change 50 with 500, I can observe. No, sorry. Stupid term. It is here. I have to modify, edit. I put here 10,000 as max. And now, if I move this in the middle, it is more or less 500. Set up, go. Okay. But where are they going, our artificial agents, when they reach the border of the world? Well, this is our choice. Let's see. Settings. The walls are green. So an agent moving on the right will be appear on the left. An agent moving down will be appear in the top side of the screen. You can imagine that this is a sphere, but the projection of a sphere on a plane is very difficult. You know the maps of the North and South Pole. They are designed in a very strange way to maintain the dimension. This is a torus. A torus is a cylinder closed to create a ring. Imagine that this ring is a cycle as a section. If I take this, I am not able to generate it. Imagine this. I cut it here. I open, and I have something close to a regular rectangle, but it's not regular, because the internal dimension of the ring is lower than the external one. So it is made in this way. But the projection of this strange surface on a plane is easier than the projection of a sphere. An agent moving on my ring never falls, is continuously on it. Indeed, here there is torus 33 by 23. If I close the horizontal movement, so the lateral walls, now red, this is a horizontal cylinder. If I close the other walls, this is a vertical cylinder. And if I close anything, it is a box. As the world is a box, it is our job to define what an agent is doing when he reaches the world. It is our job. It is not automatic. A lot of things. I am here, I stop. Or I turn back and I restart. But with an angle, if I am arriving with this angle and we restart with this angle, you know, it is completely illogical. Not easy. Mainly using angles is always complicated because you need to use trigonometric functions. Sometimes it is absolutely necessary to close the wall, mainly when you are creating networks. Because if you will see next week, if you are adding links, we are in this, and we create a network. Each one of us linked to everyone. I am moving, I go in this direction, and I stop. If the world is open, I jump beside you. So the movement of the link is very strange. But this is not the main problem. The link between me and you is passing behind if the world is open. So you cannot read the network. If you close the walls, you can. In this case, with closed walls, if I execute the simulation, setup go, I raise an error. As an agent is reaching one of the walls, here, cannot move turtle beyond the world's edge. Error. Stupid user. You have to put there an if. Okay. Now, try to imagine in Python, in C, what you want, to generate the same situation. What do you have to do? Calculate. Sorry? No, open. Close is very simple. Sorry, you are right. I have misintroduced the question. Try to imagine to manage an open world, a torus, generated by a Python program. The reply is here, anyway. But try to imagine before I introduce it. This is always the red flagged file. Anyway, in the homework you have the exact names. We need to use a lot of if or to use math to make calculations. The best math possible is the calculation of the remainder of the integer division. Let's see, it's very interesting. It's a universal trick in agent-based programming. First of all, open my friend Python. And try to reply to this question. 1 divided integer division by 3 is 0, and the remainder is 2. But Python can calculate it. Sorry, 1 person. Oh yeah, 1, not 2. 1 divided 3. The remainder is 1. Okay? Imagine to have this word. This one. With the position 0, 1, 2, 3, 4. We are managing only the horizontal movement. For the vertical is the same, sure. If I am here and I move on the right, I have to jump here. Does it work? Yeah, because the dimension is 5. This is 5. The integer division of 5 by 5 has 0 as remainder. So I jump here. Okay? You are astonished. It is simple. Do you agree? I hope yes. No. No one agrees. Help me with question, please. I repeat, I am in 4. I move on the right. So I am in 5, but 5 does not exist. I calculate the remainder of the division of the position by the dimension of the word. The remainder is 0. So the agent is moving here. If I am in 4, 4 divided 5 has remainder 4. So it does not move. Okay? Nope. No.
Okay, so the real position is the remainder over that position.
The position is the remainder of the position divided by the dimension.
By the dimension. Okay. So when you go in 5, it will be 0.
If I go in 5, I am in 0. And this is exactly the effect of going on the other side. But what if I go in -1? There is a simple solution in the program. We will see the simple solution. And there is an abstract one mathematically perfectly consistent with the theory of numbers. You never managed probably integer division with the negative numbers. One negative and the other one positive. The definition is not simple because, where is my Python? It's here. -1 divided by 2 is not 0. The integer division, sorry, is not 0. It is -1. It is complicated. You have to reverse the word. Our integer division is the floor, correct? 1 divided 2 is 0.5 as a real number. As an integer number is the floor of the number. And -1 divided -2 is -0.5. And what is the floor of -0.5? -1. The floor is the basis. If the level is 0.5, this is 0.5, the floor is 0. But if this is -0.5, the floor is -1. This is an abstract theory of numbers. And it's perfectly consistent with the remainder. The remainder is always positive by definition. In this case, the remainder has to be positive to create the consistency of the calculation. -1 percent 2 is 1. Let's try. The result -1 times 2 gives -2 plus the remainder 1 gives -1. The unique languages in the world doing that are Python and Julia. Because Julia is copying Python, and Python has been created by a mathematician. If you do that in C, you obtain always 0. It's not correct. The same is 1 divided by minus 2. It's the same. Discordant signs. And so this is a wonderful trick, because if my agent is in minus 1, the remainder with 5 is 4. Exactly the position where he has to jump. It is here, it is appear here with this movement. Okay. In Python you can do that. It is wonderful. But it's not a strange idea. It's the power of the consistence of Python with math, theory of number. The program comes from an implementation in C, in Objective-C, where this kind of thing does not work. So there is a trick, very simple trick. You simply add the dimension and the number is again positive. If you are in minus 4 and you add 5, you are in 4. The remainder of 4 divided by 5 is 4. And you jump in the correct place. But why you added the dimension? No specification. It's a trick. In the program you will find the trick. Let's a quick look to the program. I don't execute it, I simply open it. No, I execute also it, just to have the possibility of looking at the results. Tomorrow we will have an easier lesson, so don't kill me. Wait until tomorrow. If you tomorrow kill me, you are right. Creation of the world. You want to kill me?
No.
I escape.
We have first to finish the book together.
Egoistic guy.
No, I wanted to ask you a stupid question. Maybe you kill me after that. I haven't yet had the time to watch the first registration of your lesson yesterday. But in these registrations on YouTube, which will win the Oscar prize.
Yeah, absolutely. For the best actor.
I wanted to ask, do all these screens appear as well? I mean, apart from your beautiful
No, anything appear that is on the screen.
I knew it was a silly question, so that's why.
No. I am recording the screen.
You are recording the screen. So we do see also that
Yeah.
Square and all the set of instructions.
All these pictures.
And
Anything. I am.
So this silly question also will be recorded,
Absolutely. For the eternity.
Okay.
Until YouTube will survive.
Okay.
We don't know.
So the whole world.
A long life to YouTube.
The whole world will know that I'm doing now. I'm asking you a stupid question now. So the whole world on YouTube. Okay. Right.
Thanks. No, anyway, I am recording the screen. And my face is only detailed because a psychologist told me that if you never appear, it is not a conversation. Sometimes you have to be there. It is important to recover the attention. Otherwise, this will be absolutely unuseful to have myself there. And the trick as I am recording a video, but I am not saving it because the charge of the disk is already a lot charged by the recording of the screen. Internally, the screen contains the windows with my face, so I am recording also myself. It's a trick. Thanks. The bug creation is always the same with a new detail. You see the init now with a lot of parameters and also with the dimension of the word. This is a novelty in Python. You can predefine parameters. So if I will not use them when I will create an instance, they by default will be 80 by 80. Then the walk and the report position, two simple instructions. in the walk, I add a function random move doing a stupid thing. Random move is where is it? Is here. Is simply calling rand int between -1 and 1, just to show that we can create functions. It's not strategic. And finally, the actions, ordering, the movement and the report. And finally, the code. We create and bugs, asking to the user how many bugs, a list of bugs, asking the dimension of the word, and asking also how many steps in time we do. And then we have a range. The first range, do you remember time management? The first range creating agent, and the second range managing them upon time. I don't explain, this is similar to the other one, only details. If I run it, how many bugs? 4. Size of the word, 3 by 70. Length of the simulation, 2. And here are the creation and the action of our agents. Okay, very simple. Now the homework. I told you that today is a constrained homework. Tomorrow we will explore folder 4 and 5, but very quickly, to try to have something more interesting to discuss. But I will finish the conversation with the presentation of 2 wonderful books to recover your spring. The homework is this one. Sorry. Today, enlarging code does not work. Continue to familiarize and so on in NetLogo. In Start Free Basic Object-Oriented Programming Many Bugs NetLogo, create a new message from the agent. New message. Activating a unique agent in each cycle. This is difficult. Or a random chosen one. And this is too difficult. Try. If you don't succeed, send an email to me for explanations. But if you browse the handbook, the manual of Python, of NetLogo, you can easily discover what are the instructions you can use. Second homework in Python, in the same kind of object, basic object-oriented many bugs, try to memorize the agent collection, but using a list, not a vector, as before. With append, you already have used append in the introductory example we saw in the beginning of the lesson. And try to add the same modification of the NetLogo cases above. So a speaking agent doing some message. The container is very simple. The content is a bit complicated. Try. If you want to ask me for detailed explanation as you are in troubles, do that. This is a part of the teaching. This is a compressed course, 5 days, and we have to interact. Just to conclude in a lighter way, let me show you 2 wonderful free books. The first one is this book about data science in Python. Free. Is the O'Reilly series. A few of the O'Reilly series books the most successful are free because they sold so many copies, they decided to put the book on free online. Python Data Science Handbook. It is a set of programs and of explanation to do a lot of different, interesting, important things. Strange today. Okay. How to use NumPy, the numerical Python extension. How to use pandas. Pandas is, you have to imagine that pandas is a database. A database is running the content of a large file with columns, and you can open and work on the file. Pandas is very quick in execution because it is doing anything in memory. It is limited by the dimension of the memory, but if you have a larger memory, you can do astonishing things with incredible speediness. Matplotlib, how to plot, machine learning. A lot of application in machine learning, starting from the simple friend of the linear regression, because in machine learning, one of the pillars is traditional linear regression. Okay, the second book is a theoretical one, Complexity Search with Python. Again, the gift is from Orelli.
I like the bird picture.
Yeah, but I don't like to pay. This is the, sorry, is no more free.
Yeah, download this book in PDF.
Where is it?
On the top.
Ah, many thanks. You saved my life. Downloaded this. The other one are costly. Anyway, are all interesting book. Bayesian statistics, thinking in Python, think complexity, this one. Use them for your master or for the PhD, sure. Also you in educational science. Okay, now
You use them and have fun.
see you tomorrow. Many thanks for participating. Send me emails and homeworks.